All right, so we have seen oxygen nucleophiles in carbonyl chemistry. We have seen nitrogen nucleophiles in carbonyl chemistry. We've seen sulfur nucleophiles in carbonyl chemistry. And now we're going to look at hydrogen nucleophiles in carbonyl chemistry. Before we do, let me try to convince you that this is just exactly all the same stuff. And we saw this in chapter 13. Okay? So this is exactly what we're expecting. Now, let's think about hydrogen for a second. Hydrogen doesn't act as a nucleophile very often. Why not? When you see hydrogen by itself, what's it normally doing, right? When you see hydrogen by itself, normally it looks like this, right? And there's a reason for that. So in any case, this is acidic conditions with a plus. In order for it to be a nucleophile, it has to have a pair of electrons. Hydrogen's got a +1 nucleus. So if it has a pair of electrons, it has to have a negative on it. That's it. That's all we've got. And this is called hydride. So we've seen it before. We saw it in chapter 13. We saw it in chapter, where else did we see it? In chapter 8 or 9, where we saw acetylene. So either way, we've seen this before. It's called hydride. Stop and look at it. Put the lone pair of electrons on there. Call it out loud. And put the negative on there every time. Now, reagents that act like hydride ions include lithium aluminum hydride and sodium borohydride. Okay? And hydride is going to react with carbonyls just like we expected. Again, we saw this in chapter 13. These reactions we've memorized already. So let's look at this. I think we're not going to say much about this. Now, look at this. Identify the nucleophile. Pause the video here and point out the nucleophile. This is trickier than it looks. Pause the video and point out the nucleophile. Okay, I didn't tell you to do this before you paused it, but pause it again and draw out the mechanism for what you expect here. Draw the mechanism out. It's in chapter 13, but if you can avoid looking, if you can guess, you'll get it better. Okay, I'm going to suppose you did it, and I'm going to say, watch this now. You're not going to like this. Where's my marker? The nucleophile is right here. Boom. Boom. Those electrons are the ones that are doing the attacking. Now, of course, if you chose these electrons or these, you're fine. It's the same thing, right? But it's the electrons that look like they're bonded to the aluminum is the one that's the one that's gonna come in and attack. Okay. Now, is this reaction going to be more effective under acidic or basic conditions? Pause the video and say why. Is it going to be more effective under acidic or basic conditions? Pause the video and say why. I'm going to suppose you paused it. If we have this around, and this is done in acidic conditions, bam. It's just going to be a gas that bubbles off. So we will not be doing this under acidic conditions. If you do this in acid, you won't get what you're looking for. All right? Somebody says, wait a second, there's acid right there. Why is this not doing this in acid? Because it's 2 steps. All right? Show the complete mechanism. I recommend that you when this video is done, I'm not going to do it with you, but go through the entire mechanism here carefully. And again, you're doing this because it's the same thing you've done over and over and over again with many other things, and you want to get very comfortable with this. All right? Now, and also think about the reversibility and irreversibility. Which of these are going to be reversible? Which steps go back and forth? Okay, bring that question to class if it's not clear to you, and describe the necessary experimental conditions, which I've already done. All right, that's it for this section, and I'll see you in section 10.